Welcome to another Prince August demonstration. We have 3 silicone rubber moulds. The first is the one in progress, the second is a finished one, embedded master mould, and finally the third one is a cut open mould. The difference here is that this mould is made in one piece and then it is cut open with a knife. It's quite skillful work, but only suitable for simple items. The embedded mould has the master embedded halfway in plasticine. This allows you to make one half at a time. Pour the second half against the other finished half. Now to address what is needed to make a silicone rubber mould. We offer a Prince August kit which contains 1 kilo of silicone rubber in 2 half-kilo tubs. The plasticine blocks for embedding the figure and making the walls. And the Vaseline in a tub is used to separate both sides, and a brush to apply it to the base with the plasticine, and also an underlay board as well to protect your work surfaces. But there are also additional items you need to source yourself. A roller pin to flatten the plasticine, an ordinary kitchen knife, and a plastic container, usually cut from a milk container. It needs to have a reasonably flat bottom to make mixing easier. Prince August also provides a special toolkit to aid embedding the master in the plasticine. You will also need tissue paper to clean up any spillage when pouring the rubber. Plasticine needs to be warmed up. It's not any use when it's cold. So we have 50-degree temperature for about 10 to 15 minutes in an oven, just to make it more pliable and useful when we are going to be creating the base and walls for our molds. We will cut the blocks into strips using a knife. To separate them out, you'll need a couple of layers thick, so you can always layer them on top of each other, and you'll probably need about 3 segments long as well to make sure that you have a big enough base to create the mold. Once you have the base pushed together neatly, use your roller pin to flatten it. Keep rolling it out. You don't want it too thin, but you do want to get rid of all the little marks in the plasticine. Then carefully remove it from your worktop and put it on your underlay board. We are going to embed this simple plastic piece. Put it into the plasticine and squeeze it so that roughly half of it is embedded. Use the tool to make sure it is a tight seal with the plasticine all around. The more care you take at this stage, the less of a problem with the shift line later. Next, we need to add an ingate into this mold. It is very important as it feeds the gravity pressure on the casting. It also acts as a funnel for the metal. This came from a Prince August casting. We simply cut it off and repurposed it here. Make sure you embed it properly. The plasticine needs to form a 90-degree angle all around it. Otherwise, when you put pressure on the mold, both sides could slip. Keep them as straight as possible. Tidy up any gaps, as the more time you spend here, the more problems you avoid later. Remember to bridge the master with the ingate so that you end up with no gap between the two, as you do not wish to have a dent between the ingate and the master. Clean up any remaining marks between the two parts and smooth off the joining between the plasticine and the metal masters. Once you've completed that, then we can move on to trimming up the mold. The first cut should be right by where the ingate ends. A nice clean cut straight down from there. Then you want to give about 20 millimeters at either side and a little bit longer at the bottom. Cut carefully and again slice away the unnecessary parts of the plasticine that can be reused for future projects. Nice even cuts are important to avoid any problems later on when it comes to putting a wall on the moulds. Now that you have removed the excess from the base, we can now round the corners to make it easier to put the walls on. To do this, simply cut off the tips of the corners and round them off with your knife to create no area for gaps when you're putting the wall on. The reason we put the ingate at the pole rather than at the top was to avoid what we call backfill. We want the metal flow down the channel and avoid getting restricted by air or gravity resistance. So if we were to put it at the other end, it would fill down one side, go down the pole, and then it wouldn't fill up the other side, at least not properly. But instead, what we do is we place it at the bottom and it will simply flow all the way up, right up to the top and up to the two prongs, allowing an easy process for casting. To prepare for the walls, we cut strips off a block of plasticine, a couple of strips just to be sure. Now we use the roller pin to flatten those strips out so we don't end up with the marks in the middle of the strip. Nice even flat strips, not too thin. Then remove them carefully from the table. We use a knife here to just help slice them away from the table, and then attach it all the way around the mould. If you have a gap that you still need to fill, use the other strip appropriately. You don't need to use the whole strip, cut the parts you need, and then attach it and blend it together to create a fully sealed wall 360 degrees around the mould. You want to avoid any gaps with the base, as that could result in leakage, which is something you definitely do not want. And there you go. The mould now is one step closer to being ready to pour. We use a biro pen, the end of a biro pen, to create small indentations in the mould to add grip, so that when the two halves of the mould go together, they are less likely to slip. Each indentation is about 3 to 4 millimeters deep. We're using about 6 different indentations in this mould. Just push the pen in, make sure it's a nice even flat indentation, and that will improve the grip of the two halves of the mould. Okay, we have to finally apply the Vaseline with the brush onto the base of the mould. This helps stop the two sides sticking together. Just apply a nice even layer. You want it to be thick enough to make sure that it's easy to open, but you don't want any lumps. So take your time, cover every single section at the bottom of the mould, including the indentations, to make sure that there's no area that's going to rip or pull or adhere to each side. Also do it on the master as well. Now we're going to get the dimensions of the mould so we don't end up making too little rubber or too much rubber. So it was 120 in length and 70 in width, and we're looking at about 12 millimeters in height. So we have to calculate all that together by simply multiplying all those numbers. That's 120 multiply by 70 multiply by 12. And you end up with 100,800. Now that rounds up to be about 100 grams of rubber. We go over to our weighing scales, weigh the container first, so we have a base weight for that, that's 23 grams. And then we can consider about 60 grams per side needs to go into the tub. Now the clear gel is actually quite sticky, and it's important not to mix the gels together, including contaminating them with knives. So use different knives for different tubs. If you don't do that, you could accidentally prematurely harden the rubber in the tubs. Scoop out the exact amount of rubber that you need. Don't worry, it doesn't have to be too exact, but you're looking at about 60 grams. So add that onto the 23 grams of the container, will roughly end up being 83 grams. So we've got a little bit, 84 grams there, that's enough. The blue container is a little more runny, so we have to be careful when pouring it in. Again, another approximately 60 grams added on top of the previous weight. That will bring us up to a suitable number. Put the lids back on appropriately onto the correct side so you don't end up contaminating the tubs. And you can clean the knives later. Now, the rubber needs to be well mixed. If it's not well mixed, you end up with a problem with inconsistency in the hardening. But another problem with mixing it by hand is that you will end up adding air pockets into the rubber, air bubbles, and that's something we don't want. So it's a bit of a compromise. You need to mix per 100 grams for about 2 minutes. Just carefully mix it up for about 2 minutes to get an even consistency all the way through. Allow the mould to stand for about 15 minutes, more if it's more rubber, to allow the air bubbles to rise up and be removed. Air bubbles can adhere to the master otherwise, destroying the mould. So you want to get as little of them as possible remaining. If you have a vibrator or some form of vacuum chamber, that can quickly remove them, but otherwise the best you can do is just leave it for about 15 minutes to stand and settle. You can see that the air bubbles are significantly reduced. Carefully slosh it back and forth to help make sure there's as little as possible air bubbles left. You get a nice even mixture. It's ready for pouring.